these problems are something that we will see a lot of, and it's going to be tested pretty heavily on the test. Okay, so we're going to start with example 1, which is just a review question. Okay, so example 1 just asks us to find the slope of the line that passes through 2, 7 and negative 1, 4. Okay, so just reviewing here, I could graph it 2, 7 and negative 1, 4, and I could draw.
Is it 0 on 5?
I don't think you should get a 0. I think so.
One? Hello?
All right, so
Oh, I think
I could graph it and I could figure out the slope. That's one way to do it. So everything that we're doing, there's lots of ways that you can do those particular problems. All right, graphing, if the numbers are small enough to graph at least, is a good way to go. So if I wanted to graph these 2 points and I'm looking for the slope, I could just go up 3 and then to the right 3. So my change in y over change in x would be 3 over 3, which equals 1.
Oh, I found the y-intercept instead.
Yeah. And so that is the slope of this line. There's another way I know how to find that, right? I want you guys to have lots and lots and lots and lots of tools in the toolbox whenever it comes to writing equations of lines, right? So graphing is one thing you can go to. You can graph it. You can see what the slope is. There's another way we know how to find the slope through 2 points. Who can tell me what that is? We don't have to have the graph at all for it. Tell me what is your right track.
Y2 minus Y1 and X2 minus X1.
X2 minus X1. So we can also use slope formula. That's another option, right? So if we're using slope formula, Eddie, tell me how to plug my numbers in for this particular problem.
You put in 4 at Y2 and 7 at Y1. And then on the bottom you put negative 1 first and then minus 2.
Good. All right. So in the numerator, that would give me a negative 3. And the bottom, I would also have a negative 3, which would be a positive 1. So I get the same answer that I got the other way. Okay, so 2 different options for doing the same thing here. So that's one thing that we're going to kind of focus on as we go through. There are some of you that are making a lot of mistakes whenever you do this. I think you got the general idea, but you're counting your slope wrong, or you're getting your x-intercept and your y-intercept and your x-intercept mixed up or something like that. So if you're unsure of yourself, you can always use this like a second method for figuring that out. Okay? So let's look at the types of problems we're going to see today. So look at this first one right here. Let me zoom in a little bit. Okay. Example 2 says to write the equation of a line that has a slope of negative 2/3 and a y-intercept at 0, 5. Okay. Now they have given us the slope and the y-intercept. Now, whenever I have my equation y equals mx plus b, what's that called? What's the name for that form of a line? It's not standard. Standard's when you got like 2x plus 3y equals 7. I don't usually teach it. It's slope, intercept, form. Okay? It is called slope intercept because what does the M stand for? Slope. And what does the B stand for? Y-intercept. Slope is rate of change. Slope and rate of change are kind of interchangeable, so you could say rate of change also here. So rate of change goes with slope. So slope and y-intercept, y equals mx plus b. So if they give you slope and y-intercept, you just write the equation of the line, right? So you don't have to do any work for this. It would just be y equals negative 2/3 x plus, what number do I use right there out of the 0, 5? The 5, the y coordinate, right? The x has to be 0 for that to be the y-intercept. So you have to use the number that's not 0. Okay? We good here? All right. Now, this next one's the same, but it's a little bit trickier. It's worded a little bit different, right? It still says the same stuff at the beginning. Write the equation of the line that has a slope of. Write the equation of the line that has a slope of. This time it's 3. And the last time it said and has a y-intercept of 0, 5. This says and passes through the point 0, 7. But, so it doesn't tell us that this is the y-intercept. But it is. How do I know it's the y-intercept? Okay, my x equals 0, so this has to be the y-intercept. Right? So if your x-coordinate is 0, that is your y-intercept. Think about your tables. When we were looking at tables, right? X, y. What were we looking for y-intercept? 0. So this would be like on a table, we'd have 0, 7, right? So we'd know that's the y-intercept. So in the point, this is 0, 7, that's my y-intercept. So they didn't tell me it was the y-intercept, but I know it's the y-intercept because of the point, right? If the x equals 0, then it's the y-intercept. So I can just write this equation using slope and y-intercept. So, let's see, Anna Grace, what would the equation be? Y equals 3x plus 7. Perfect. Okay, you just put your slope next to your x, your y-intercept over here by itself. Good here? All right, example 4. Write the equation of the line that passes through the point 0, negative 9, and has a slope of negative 3/4. It's still asking me to write the equation of the line. Does it give me the y-intercept here? It does, because whenever x equals 0, that tells me that this is the y-intercept, even though it doesn't say it is the y-intercept, it is the y-intercept. So, Lanaya, what would the equation be for this one? So y equals negative 3/4 x minus 9. Perfect. Okay, any questions? All right, well, let's look at this next one. Okay, write the equation of a line that has a slope of 4/3 and passes through the point 6, negative 2. All right, so it gives me my slope. Does this one give me my y-intercept? No. This point right here, and I put a graph with this one so we can think about what it looks like. 6, negative 2, that's right here. That is not the y-intercept. Okay? So this is going to be different. If they give you the y-intercept, it's pretty easy to write. You don't have to think about it very much. But if they give you a slope and then a point that is not on the y-axis, you're going to have to think about this a little bit harder. Now, I do know, what's my slope 4/3. So like from this point, my slope tells me to go up 4, to the right 3. And if I wanted to go the other direction, I could go down 4 and left 3. 1, 2, 3, 4. Okay. So if I draw in this line right here, can we write the equation of this line? We can now, right? We know we got y equals 4/3 x. And Haley, what's my y-intercept on this one? Okay, y-intercept. So where this line crosses the y-axis. So look at the graph. Where do we cross? This is our x-axis right here. This is our y-axis. Where do we cross this y-axis? -10. So we'll have -10. At first, you said -2. Where were you getting that from, Haley? Right here. But does your x equal 0? No. So that's not your y-intercept. So you don't want to just use that -2. But I see a lot of students do that, so you got to be careful. So the graph is really helpful here. It worked out for us. But this graph just about went off of the graph, right? Sometimes this is not fit. So I want us to be able to do this algebraically as well, to be able to do it without a graph at all. Now, whenever you have, when we finally have a test on this, which this is sort of a longer section, and we have to do midterms next week, so we will have the midterm before we have this test. So we won't test on this for a little while. But when we get to the test on this, and there'll be some of this stuff on the midterm, I don't care how you solve it. If you graph it, get the answer, that's fine. If you do it algebraically, get the answer, that's fine. But there will be some problems, the numbers will be too big to graph on, so you'll need to be able to do it algebraically. So today we're going to practice doing this algebraically, okay? Algebraically meaning we're using the equation, not the graph. But you can always check yourself with the graph. So I know, right, so algebraically, I know y equals mx plus b. That's my formula that I use. So let's pretend we don't have a graph. Let's pretend we're trying to do this all just from the formula. So from what I'm given in this equation, not thinking about the graph, what could I plug into y equals mx plus b? Aiden? That will work, but sometimes will not be easy to do depending on what your numbers that you have, what numbers you have. So while that does work, if we had 5/7 and the point 2-1, something like that, it would not work so well because we wouldn't be able to do it quite the same. But that's not a bad strategy. So what I want us to do is I want us to use this method here that will work well even if our numbers are crazy, even if we have decimals, even if we have crazy stuff that we can't do and might even need a calculator for. So I know the slope is 4/3. So I am going to go put slope right here for the m. So that gives me y equals 4/3 x plus b. So I've already got the slope. To get the equation of this line, what else do I need? I need the y-intercept. I need to solve for that b right there. I cannot solve for b whenever I have x and y in my equation. So, when I have this point, 6, -2, 6 is my x coordinate, -2 is my y coordinate, correct? All right. So that means if I plug 6 and negative 2 into this equation, it should work because it's a point on the line. So what I can do is I can replace 6 and x and y with 6 and negative 2. Okay? Oh, can somebody let them in? I don't know. What you need, dear? What did I tell you about coming? Your jersey is on backwards. Hunter, you just lost it right there underneath Lexi's desk. Oh my goodness. I told him he's got his snacks before here. Yeah. This is what life is like as an actual soccer mom. Yeah. I hope so. I hope he's not out there on the field.
Not gonna lie, that'd be very funny.
Yeah.
That'd be very funny.
Wait, does he have a home game too?
Away. It's at Gentry today. No, they were pretty good. They were decent. I mean, we beat them the first time, but it was like 1-2. They were decent. So, Gentry's where I went to middle school long ago. I loved it when I was there. It was a good school when I was there. Mm-hmm. That's not good. It could be when the principal doesn't like you, it could be because they're an unfair person. Or it could be that they've been given a reason. Alright. Look, I'm going to tell you, I tell my kids, Haley, hate is a strong word. And we reserve it for things that we actually hate. Okay, that's a better way to word it. And also, probably, you know, especially whenever it's people that don't even know, you know. I don't want people to, like, hear me saying mean things about this. So. But hate is a strong word. Don't use it all the time. All right. Okay. All right, so we are going to put, right here for the y, we're going to put negative 2 equals 4/3. For the x, we're going to put the 6, we're going to put it in parentheses because those two things right there are multiplied together. And we put our plus b. Remember, b is what we want to find. We need to know the y-intercept, right? So, I've got to solve this for b. Before I can do that, I need to multiply 4/3 times 6. Almost. Only if you're dividing.
Oh.
Dividing is when you flip the second multiply. So we're not going to flip it. We're just going to put it over 1. And you're multiplying straight across. You're going to get 24/3. What is 24/3? 8. You want to, most of the time the fraction goes away. Not always, but most of the time. So some people leave it 24/3 and then they make their life difficult by having to deal with fractions past that point. So make sure you check to see if that will actually divide. So we got negative 2 equals 8 plus b. We're trying to get that b right there by itself, which means we got to get rid of the 8. How do I get rid of the 8? Subtract it. So I'll get negative 10 equals b. Right there is my y-intercept. I already knew it, right? That because I'd done this one with the graph, and that confirms that this was correct here. So this will be our answer. Okay, so whenever you're doing these problems, if you have small enough numbers, you can do them algebraic. I want everybody trying them algebraically today. I do not want you just graphing them today, even if they're small numbers, because Delta Math probably was going to give you small numbers. I want you doing these algebraically today, but you can always check with the graph. Okay, if you want to check to see if you're right with the graph. So let's do a couple more, and then we will. Well, no, actually, we got 4 more. All right, so we're going to do these algebraically. That means we're starting with y equals mx plus b. I already know my slope, so I can plug it in, right? Y equals 3x plus b. Don't know what b is? That's what I'm trying to find. So I know that -5 is my x-coordinate, -2 is my y-coordinate. I can plug them into this equation, right? So y would be -2, x would be -5, okay? So I'm going to get -2 equals -15 plus b. And that b right there is what I'm trying to get. So, Savannah, what am I going to have to do? Okay, well, I add that 15. And I'm going to get 13 for my b. That's my y-intercept. So my point is to write the equation of the line. Now I have the slope and the y-intercept. So the equation is going to be y equals 3x plus 13. Your final answer, you don't plug the -5 and the -2 into your final answer, because then you wouldn't have any variables and you wouldn't be able to graph that, right? So your final answer is not going to have that -5 and -2 in it. You have the y and the x there. I did. -2 plus 15 is 13. Yeah. Okay, questions?
No.
All right, let's do another one. And then we'll do a couple application problems. So slope is 1/2. Point on the line is -8, 4. So I know y equals 1/2 x plus b. So Kaylee, tell me what I'm going to plug in here. What will it look like? You sure about that? Okay, 4. 4, and then we'll have 1/2. What goes there for the x? That's where our -8 goes. All right, because we're plugging in, this is my x-coordinate, and this is my y-coordinate. What am I going to get after that, Kaylee? Good. And what do I get when I do half of -8? -4. So I'll have 4 equals -4 plus b. We're trying to solve for this b right here. So what's the last thing I'm going to do there, Kaylee? Good. So 8 is my b. That is my y-intercept. So Eddie, what's the equation of the line? Y equals what?
Y equals x plus 8.
Perfect. Okay. Questions? All right, let's look at a couple other problems here. All right, so number 8, write the equation of a line that has a slope of 2/3 and passes through the point 6, 0. Is that a y-intercept? No, it almost looks like 1, but the x has to equal 0. So this is the x-intercept right here. It doesn't help us. All right, so let's see. Caitlin, help me out on this one. I'm going to have y equals 2/3 x plus b. What can I plug into that? Okay. What do I plug in for the y? Good. I'll have 2/3. What do I plug in for the x? Good. Alright. I got to do 2/3 times 6. I'm going to put that 6 over 1. What am I going to get? 4. I'll get 12 divided by 3, which is 4. So I get 4 plus b. And then what do I do, Caitlin? Subtract that 4. So negative 4 is our b. That's our y-intercept. So what's the equation of the line, Caitlin? Good. 2/3 x minus 4. Okay. Giancarlo, help me with this last one, and then we're going to get to our work for today. I've got a slope of -1, and it passes through the point -3, 4. So I know I need y equals -1x plus b. What can I plug into that? Good. All right. -1 times -3 is going to give me 3. And then what's the last step I need to do there? Good. So that gives us 1 for our y-intercept. So, Giancarlo, what is the equation of the line? I need something else with it. You're close. X plus 1. Good. Leave off that x and it'll be wrong. Or you can write it like this. Y equals -x plus 1. That's probably what it'll look like if it were like multiple choice. Okay, questions? All right, your assignment is Delta Math. You're just going to get a bunch of problems like this. I want you doing them algebraically. You can graph them to check if you want, but I want you doing it this way because I want this to be a method that we have practiced and understand to do. Boards are fine, yeah.